So in this video, we will do a problem on line balancing using RPW method, or it is called rank positional weight method. Okay, so this is the method we are using for line balancing here. So this is one of the method used for line balancing. So let us understand this method with the help of an example. So the example given is design an assembly line to produce 40 units in an 8-hour shift. So that will be the, we will do the line balancing for this one. And then they are also given 24 units in an 8-hour shift. For this, we need to do another line balancing. And the precedence relationship and durations are also given below. For machine 1, machine 2, machine 3, machine 4, machine 5, machine 6. So for machine 1, the duration is 5 minutes, and for machine 2, the duration is 3 minutes. So for machine 2, the predecessor is 1. Okay. So for this problem, we will do the RPW method consists of 5 steps. In the first step, we will find the cycle time. Okay. So how will you find the cycle time? To find the cycle time, so it is given that it is an 8-hour shift. So 8 into 60, that is the total minutes taken, divided by 40. So you will get this as 12. So the cycle time is 12 minutes. That means every 12 minutes, a product is manufactured. So the second step is to draw the network diagram. So we will do that right now. So the precedence diagram is given. So let us start with machine 1. Okay, so this is machine 1 and it takes 5 minutes. So let us write 5 here. And after machine 1, you have machine 2. Okay, so 2 will start only after the operation 1 is completed. So here it will go like this, and then you have 3. Okay, so this is 3. Below 2 we'll write it as 3, and below 3 you will write it as 7. And then you have the fourth machine. It will start only after 1 is completed. So we will draw it like this. Okay, it is 5. Right, then the machine 5, operation at machine 5. So it will be complete, start only after 3 is completed. So that is, okay, so here it is, it will take 6 minutes. So it is 6 minutes. Okay, it is 6 minutes. Then you have machine 6. It will start only after 3 and 4 is completed. So let us draw 6 here. It will take 3 minutes. Then you have, after that you have 7. So 7 will start after 2. So let us draw 7 here. So 7, the duration is 4. Then you have 8. Operation 8. It will take start only after 5 and 6. It is given here. And it has got a duration of 6. And then you have the ninth operation. It will start after 4. It is, so the duration is 12 minutes. And then you have the 10th operation, the last operation. It will start only after 7, 8 and 9. So you can write it as 10 here. So it is 10. So the duration is 9 minutes. Okay, so this is how you will draw the network diagram, right? And we have written the duration in minutes below each node, that is from 1 to 10. The third step is to find the ranked weights or weighted times. Okay, so the weighted times. Right, for that, so let us draw the weighted time here. So for that, okay. So for operation 10 to complete, it will take 9 minutes. So let us write the 9 here, right? Okay, then. And for operation 8 to complete, so the weighted time for 8 is 50. Okay, this is calculated based on this, because for operation 10 it will take 9 minutes, and for operation 6 it will take 6 minutes. So 9 plus 6, it is 15. So that is the weighted time for the node 8. And for the node 5, so we will calculate this as 6 plus 6 plus 9, that is 21. Okay, this is 21. And for node 6, it will be 3 plus 6 plus 9. Okay, 3 plus 6 plus 9. So it will be 18. Okay, this will be 18. And now, okay, so this is 21, this is, and this is 18. And for node 3, it will be, so from node 3 you can see that it goes in two ways: 1 2 3 5 8 10, and also 3 6 8 10. So you need to sum up all the values, that is for node 3, that is 7 plus 7 plus 6 plus 3 plus 6 plus 9. So it will be 31. That means, just understand like this: if you drop an ink here, so where all it will travel? Okay, it will travel to all these paths. So then you need to sum up the time of all the nodes through which the ink passes. So you will get it as 31. Similarly, you can calculate for 7 it is 13, and for 2 it is 16, and for 9 it will be 21. Okay, then for 4 it will be, again for 4 you need to sum. See, it goes like this through 6, 8, 10, and also to 9 and 10. So it will be 3 plus 6 plus 9 plus 12. It will be, so plus 5 also. So for this 4, so it will be 35. Okay, similarly for 1, so some for 1 you need to add all the values downstream, so it will be 60. Okay, so we have found out the weighted times. So then we will draw the assembly line. Okay, this is the fourth step. We will draw the assembly line. Okay, for that we will draw a table. So here you can see this is the table we are drawing. So in column 1 you have workstation, and in column 2 you have eligible jobs, and in column 3 you have assigned jobs, and in column 4 you have remaining time. Okay, so for this we will start with workstation 1. Okay, so for this line balancing we will group these activities into several workstations. And we have found out the cycle time as 12 minutes. Okay, so let us start with workstation 1. Okay, so what are the eligible jobs that can be included in this workstation? That means the eligible jobs are 1, 2, 3, like that. Okay, when you start this, the cycle time is 12 minutes. So each workstation can take a maximum of 12 minutes, right? So that means initially the remaining time is 12. That means we have not found out any eligible job. So first we will include 1. Okay, it will take 5 minutes. So we have included 1. So these are the eligible job. So we will assign the job 1. Okay, and the remaining time now is 7. And now you can see that, so what are the eligible jobs? Okay, so for finding the eligible jobs you have two conditions, that is eligibility is based upon two things, that is preceding task assigned and time required is less than time remaining, less than or equal to time remaining. So these are the eligibility criteria. So let us look at the find the eligible jobs now. So you can see that for the preceding task completed, that means if you select 2, the preceding task 1 is completed, so you can do 2 now. And for the duration for 2 is 3 minutes, okay, which is less than or equal to the remaining time. So 2 is eligible. Okay. What about 3? The preceding task 1 is completed and the duration for job 3 is 7 minutes. So 7 is less than or equal to 7. So 3 is also eligible. So what about 4? So preceding task 1 is completed and it will take a time of 5, which is less than or equal to the remaining time 7. So 4 is also eligible. Right. So out of these 3 jobs, which job you will select? So that will be based on the weighted time. So you will look at the weighted time here. So here you can see the weighted time for 2 is 16 and for weighted time for 3 is 31 and weighted time for 4 is 35. So highest weighted time is for 4. So that means you will assign 4. Okay, you will assign 4. So it has got a duration of 5. So the remaining time is 2. Okay, so after 4 is completed, what are the eligible jobs? So you can see that there is 2, 3, 6, 9. But if you look at the duration of these jobs, it is 3, 12, 7, and 3. But we have only remaining time 2. So you cannot assign any more jobs here. So we will finish with this workstation. Okay, so this workstation has the maximum number of jobs assigned to it. So now we will design or go to the next workstation. So here let us look at the eligible jobs. So you can see that the remaining time, the cycle time is 12. That is, initially there are no eligible jobs. And then for 2, so what are the eligible jobs right now? Okay, so you can see that for 2 and 3, these are eligible because 1 is already completed and 4 is completed. So you can select, so 2, 3, 6 and 9 is eligible. So you need to also check the duration time also. For 9, you can see that the duration is 12. Okay, and for 6 it is, so 3. But 6 is not eligible because the preceding task 3 is not completed. Okay, so only jobs 9, 2, 3 are eligible. Okay, so 2, 3 and 9, these are the eligible jobs. So out of which job you will select or assign to this workstation 2. So let us look at the weighted time. For 2 it is 16, 3 is 31 and for 9 it is 21. Of course 31 is the highest, so you will select job 3 to this workstation. Okay, so first you will assign 3 and the duration for 3 is 7. So the remaining time is 5. Okay, so after that, which job you will select? So eligible jobs are, again, you have 2 and 9. So after 3, you have 5 and 6. Okay, there are 4 jobs, but you need to check the duration also. You have only remaining time of 5. So the 5, the duration is 6, so it is eliminated. So that job cannot be selected. And 6 can be selected and 2 can be selected. Okay, what about 9? Because here duration is 12, which is greater than that of 5, so it cannot be selected. So it is 2 and 6. So the assigned job is so the assigned job for need for 2 out of 2 and 6, you can see 2 and 6, the weighted time is 16 and 18, so you will select 6. Okay, so 6, so 6 for 6, the duration is 3 minutes, so the remaining time is 2 minutes. Okay, so you cannot select any more jobs because all the duration of all these jobs are greater than 2. Okay, so the workstation 2 is over, and for workstation 3, okay, so the remaining time starting with is cycle time is 12. So we will start with, so the eligible jobs are, so 2 is still an eligible job, it is not completed, and we have assigned 6, 3, 1, 4, etc. So these all are completed. So 2 is eligible, and then 5 is eligible, 9 is eligible. Okay, so 2, 5 and 9 are eligible. So out of this, the highest weighted time is for 9, so you will assign 9. So duration for job 9 is 12, so you have 0 time remaining. Okay, so the workstation 3 is over, so we will move to workstation 4. Okay, you have, now you have 2, 5 and, okay, the remaining jobs 2, 5. So 8 cannot be selected because see, 5 is not completed, so there is 9 also, so it is, so 9 is already assigned, so the remaining jobs are, so first we will start with 2, 5, starting time is 12. So you will assign the job 5, because if you look at 5, you can see that the waited time 21 is greater than that of 16. So it is 21. That means, so duration for job 5 is 6. Okay, the remaining time is 6. Now the remaining job is, okay, 5 is completed. Now you can do 8 because 5 and 6 both are completed. So for 8 the duration is 6, and for 2 the duration is 3. So it is 2 and 8 are eligible jobs. Out of this you will assign 2 because 2, the waited time is 16, and for 8 it is 15. So 16 is greater than 15, so you will select 2. So now the remaining time is 3. So you cannot find any more jobs here. So you will move to, because the duration of all the jobs is greater than 3 after that. So you will move to workstation 5. Workstation 5. So here the cycle time starting is 12, and the eligible jobs now is, so you can see that you can have 7 and 8. Okay, 7 and 8 are eligible. So out of 7 and 8, the rank weighted time is 13 and 15. So here it is. So you will select 8. So duration for 8 is 6. So the remaining time is 6. So next the eligible time is 7. Jobs are 7, you will assign 7, and remaining time is 2. So the workstation 5 is over because all the jobs after this have duration greater than 2. Then we will select the 6th workstation. So here initially the cycle time is 12, only job 10 is remaining, so you will assign 10 and remaining time is 3. Okay, so this is how you assign the workstation. Okay, now we will calculate the efficiency of the workstation, that is the 5th step. So that is defined as the consumed time divided by the design time. So consumed time is the total time taken, that is 60. Okay, it is 60 divided by, so design time is you have totally 6 workstation with a cycle time of 12. So 12 into 6, that is 72. 60 by 72 into 100 in percentage. So you will calculate it as 5 by 6 into 100, that is equal to 83.33 percentage. So this is the efficiency of the assembly line. So this is how you design an assembly line using the rank positional method. So the steps are, you will calculate the cycle time, then you will draw the network diagram based upon the precedence given, precedence chart. Then we will find the weighted time, and then we will draw the assembly line. That means we will find out the workstations, which all jobs should be done in which all workstation. Then we will finally calculate the efficiency. So this is all about the rank positional method.